The universe is expanding, but how fast? That should be a simple question. Yet scientists have two ways to measure it, and they give two very different answers. For years, we hoped this was just a mistake, a glitch in our telescopes. But now, the Atacama Cosmology Telescope, or ACT, has confirmed the disagreement is real. It isn't a fluke. It's a crisis that could rewrite everything we know about the cosmos. Astronomers have a name for this conflict, the Hubble Tension. To understand why it's so alarming, you have to look at the universe's speedometer, the Hubble constant. This number tells us exactly how fast space itself is stretching. Here is where the tension begins. If you look at ancient light from the early universe, the cosmic microwave background, the speedometer reads one value. But if you look at nearby galaxies and supernovas in our modern neighborhood, you get a significantly higher value. According to our standard model of the universe, these two numbers should match, but they don't. Something is fundamentally off. From 2007 to 2022, the Atacama Cosmology Telescope, perched 5,000 meters high in Chile's desert, scanned the oldest light in the universe, light from just 380,000 years after the Big Bang. Its final data release did three remarkable things. First, it confirmed the tension is real. ACT's measurements match the Planck's satellite's results perfectly. This isn't a fluke or a measurement error. The discrepancy with local galaxies is robust. Second, it created unprecedented maps. ACT produced the sharpest ground-based polarization maps ever. One scientist described it like cleaning your glasses. The cosmic picture is finally in focus. Third, it asked 30 proposed solutions. This is the big one. For years, theorists had the most wanted list of solutions to bridge the gap between these two expansion rates. Early dark energy was the top suspect, a ghost-like force that supposedly kicked the universe into high gear shortly after the Big Bang. Others blamed modified gravity, suggesting Einstein's math simply broke down over vast cosmic distances. But the ACT data just tore that list apart. It tested over 30 of these new physics models, and one by one, the data ruled them out. They simply don't fit the reality we see in the ancient light. Confirming a problem while eliminating 30 solutions might sound discouraging, but scientists see it as massive progress. It narrows the field. It tells us that the answer isn't a simple tweak to our current math. The Hubble tension hints that something fundamental is missing in cosmology, perhaps an entirely unknown feature of the early universe is waiting to be discovered. By ruling out these 30 models, ACT has cleared the path for an even deeper breakthrough. The Atacama Cosmology Telescope's successor, the Simons Observatory, is already scanning the skies. With even greater sensitivity, it could finally reveal the missing piece of the puzzle. So next time you look up at the stars, remember, the universe is expanding, but its speedometer is broken, and scientists are racing to fix it. The Hubble tension is real, our models are incomplete, and the universe still has secrets to reveal. Will we ever understand how fast space is stretching? Only time and the next generation of telescopes will tell. Thanks for watching. If you found this video helpful, give it a thumbs up and don't forget to subscribe to the channel.